So hello everyone. We're really pleased to start the second Scicloj gathering with the great Carin Meier, who, as you can see, of course, is going to talk about MXNet and Clojure. We're recording this because we're going to release this on YouTube in the next few days. So if you have problems with that, you know it right now. It's okay, and of course, then you can share it if someone wants to see it and it wasn't possible for them to join the meeting right now. So without further ado, actually, Carin, if you want to start, we're ready to hear you.
Sure. So can everyone hear me? Yeah. Yeah, I have the chat over my other window. So I'll look over at that occasionally too. So if you want to put questions in there as I go along, I'm happy to take questions as we go. This isn't like a, like a big formal presentation or anything like this. So it's more of a, just explaining things and, showing where we are in the community, some challenges, so we can open up a larger discussion, afterwards. So that's the point. So I'll kick it off. So MXNet, deep learning and Clojure. So what is this deep learning, machine learning stuff, and how do we use it in the language we love? So that was what this is all about. So first, what is MXNet? You probably, if you may have not heard it, but it's a deep learning framework. So it's an Apache project. It's incubating. I'm just going to bring up the website here. I have a whole bunch of. So here's a website for it. It kind of explains it better. So it's incubating. So it's not quite graduated yet. It's getting close to graduation, but it's still in the incubation phase of being an Apache project. And we can talk more about that later of what that means. But it's a flexible and efficient library for deep learning. If you talk to anybody about MXNet and they know kind of anything about MXNet, is really known for its performance. It's one of the fastest, most performant deep learning library out there. Let me see, there's lots of different languages. The higher level languages, there's Python, look, we're there, Clojure, woo, Java, Julia, Perl, R, Scala. So it also uses TVM. We had the presentation last time on, TVM, a lot of the stuff with the tech.ml. So the core, this is actually kind of an important part and distinction in my mind with the other deep learning frameworks like TensorFlow. The whole core of the framework is in like C, C++. And the higher languages wrap around that API and build on it. Now this is opposed to like TensorFlow, as I understand it. I could be wrong in this, but when I've talked to people, this is sort of the challenges that they tried in integrating with it, is that only part of it is in, the part of the core is in like C stuff. And the rest of it is actually core in Python. So to interact with the C stuff, you actually have to build out the stuff from Python and port it into C, which is a lot tougher way to go. So those higher languages wrap that C API. Python is probably the biggest one. Scala, Julia, and R, and us. And there's also a Perl one, but it's not active. So it's kind of like a legacy, but it is out there. So what can you do with MXNet? You can do all sorts of deep learning tasks. And one of the classic ones that you'll see a lot are image recognition, image classification. You can tell whether things are cats or dogs, or especially recognize human faces. That's like an important thing now. And for us, for like industry stuff, we can do a lot of stuff with text. So text sentiment, whether it's a positive or a negative sentiment, or what this article is about, summarization, classification, is it a legal document, is it something else? You can do question and answering now with it. I'm going to actually show a demo of that. Text extraction. You got a document and you want to extract some sort of text and not in a brittle, rule-based fashion. That's also a good use for it. And there's like tons more that I haven't touched on. There's all sorts of things. You know, there's reinforcement learning. There's GANs, so generative stuff. There's just a whole rich field of things you can do with deep learning, and we've only scratched the surface. Oh, you know, play Go. But I haven't done that with MXNet, but theoretically you could, right? So let's talk some real talk about deep learning projects. The real talk is that this is dominated into a pretty few major deep learning frameworks that people use. And you'll notice that there are some names next to them. And we all know Google with TensorFlow, PyTorch is kind of backed by Facebook, and MXNet is backed by AWS. And why is this important? Because this field is moving fast and furious. And to keep up, you really need a company backing it, putting time and resources and effort into it. And these are the frameworks that these companies are supporting. So saying this, it's really hard for a small player to come on the field and compete with these other deep learning frameworks. If they're like, okay, yeah, we got like 3 developers, we're going to make a deep learning framework. Well, you can, but you know, this is a reality. This is a reality of a successful deep learning framework project. And actually, if you're talking about like open source in general, it is the trend to have a really big, successful open source project. You're going to have backing by a company that's putting full-time developers into it. That's just the way it is. The other kind of reality check sort of thing that I've noticed a lot as I've gotten into deep learning, and I've attended conferences, I've attended like NeurIPS, I've attended ACLR, I've read like all the blogs, and I have a semi-good, at least for me, I think I have a heartbeat of, you know, what is going on in this deep learning community. And this was actually, there was another talk, and it was video broadcast by, I think, Arya. I think he mentioned this too. So there are a lot more people talking about deep learning than actually doing it in real industry setting. And by talking, I'm putting that into research. And I'm not saying talking in a bad way. So kind of a non-application industry using it. There are way more people exploring it, talking about it, playing with it, than are actually deploying it in production and using it. So what does this mean? Well, it's interesting because if you look then, and this isn't totally my opinion on this, so take it with a grain of salt, but TensorFlow is by far the leader in deep learning frameworks right now. But from what I've heard, it's really hard to put that into production. Performance-wise, there's all sorts of other struggles with putting that sort of code into production. Python-based. Same with PyTorch. I mean, they're like dominating the research field right now, just kind of dominating it. But then you look at MXNet and AWS, and industry and putting stuff in production is AWS's bread and butter. And I think this really marries well with MXNet's strengths, with its performance, and also the multiple languages that it can run on. You can run it on JVM. You know, it's not limited to just the Python ecosystem. So I think that MXNet and AWS, they're really poised for success for leveraging deep learning in a production industry setting in the next years. So they're like in third place right now, I would say, for the deep learning frameworks, but I expect them to really tip up very shortly. But again, this is my personal opinion on this. Okay, so let's talk about the Clojure package and how it is built within this MXNet framework. So we talked about how there's a C core. Historically, the Scala package was built first. It was the first language to build out the C bindings for the JVM. These are by J&I custom bindings. The Clojure package wraps this Scala interface and uses JVM interop to do this. The underlying tensor structure that is used is ND arrays. So this uses TVM under the covers, but there isn't an option to like plug in whatever sort of tensor package or library that you want to use. You actually have to use, this is part of the framework, you have to use ND array. So this is totally a valid response because this is the first time, you know, I was in it. I was like, oh, you know, I don't want to use Scala. I want to just keep it pure Clojure. What can I do? So I get a lot of reactions that people are like, you know, why is it not pure? I don't want to have to deal with Scala. I don't even know that another language is in the background because, you know, it just makes me feel unpure or impure. And I'd like to, you know, take a little bit of addressing why, you know, it was chosen to do this way right now and sort of the trade-offs of it. So let's have some real talk about purity. So I love Clojure. You know, we all here love Clojure. This is why we're here. But, you know, Clojure is pragmatic. I remember people saying about Clojure, oh, you know, I really like Clojure, but it's on the JVM and I don't like the JVM and you know, we just have plain Clojure. But Clojure is pragmatic. You know, there's a lot of advantages that we get, pragmatic advantages of using libraries on the JVM. And the reality is right now, as we stand, the Clojure world is really small compared to what's out there for Python and the rest of the deep learning world. I mean, really small. I recently went to Scicloj. It's another like deep learning event. And there was like there was one other Clojurist because it was Ben from my company who went with me. But we were the only people there. And maybe like, I think it was about 3,000 or 4,000 people. So, I mean, it's really small when you get out of your sphere and your ecosystem. So we need to realize that, and we need to realize that we need to leverage and build bridges and communication as much as we can in this world. And leveraging the Scala package means that we are building ties, you know, to the rest of the development world in MXNet. You know, it gets us out of our sphere. You know, now we're kind of communicating more with all the JVM package people, so the Java and the Scala. It also allows us to leverage all the full-time developers that AWS is supporting to build out the Scala package. So I think that's a good thing as well. So as much as I would like to be pure, I think that from people and leveraging technology to get us more successful and be able to do things right now, I think absolutely it's the right choice to stick with the Scala. However, this is open source software. So if somebody really feels passionate about this and wants to put the time in, build from the base bindings, you know, you can definitely do that, and we can take that and run with it. But this is kind of a tree structure of the project. There's a lot of work that's gone on in the Scala package of just building stuff out that we can take advantage of. So the stuff in stars here, so the generated ND array and symbol stuff that comes from the base C stuff, and like some of this ND array and some of the symbol, this is what you could get if you just kind of do some direct C, J, and I stuff, or building out however you want to just directly interface to the C package. You would have to build out all this other stuff as well. So we are not only getting you know, future and current development coming from the Scala package that we can leverage, we've gotten all this other development that we can leverage without building it ourselves as well. Okay, so let's talk about the state of the Clojure MXNet package. So I think it was July when the PR, last July when the PR got accepted that it was actually part of the larger Apache MXNet project. So we've been part of the main package for nearly a year. We're still kind of under this contrib closure, but we're nearing graduation out of the contrib. You know, I think what we'll do is, you know, take an inventory of where we are and how far we've come in a couple months, and put out a vote and discussion to the group to have us graduate out. So I think we're pretty near that point. We're gaining contributors and committers, which is wonderful. This is what we want to have happen, and get more people involved and grow the package. We have one PMC member, which is me right now, but again, hope to get more people up there. What is this? This is the Podling Project Management Committee, because we're still incubating. It's called a Podling, but the point of this project management committee is it gets voting rights. We look at the long-term health and growth of the MXNet project and help vote on bringing new members in. So it's great, I think, that Clojure has a long-term kind of steering direction seat at the table. And so far, everybody working with has been very collaborative, and it's been a great environment. And this is across many languages, and high and low on the, you know, down to the metal part up to the top. So it's very good. So it's actually I'm a committer as well as a PPC member, so that's like 2 committers, and there's more to come. So the other thing that I like about this is that each committer that is admitted into the, you know, larger group with commit rights, this is not just a Clojure person voting on, you know, who would be a good person to have in as committer. This is people, you know, across the Scala package, across, you know, Python. I mean, it's this larger group. So it's really community. And so being admitted into a committer, I think, is a really big deal, because that's like in a larger community setting of just bigger than Clojurists. So I think that's really great. Over 115 Clojure PRs have been opened and merged across this nearly year, and this is cross-language too. So we've had Clojure people doing Scala stuff, Scala people doing Clojure stuff. Java stuff, and you know, it's really good to see the collaboration. I like, and we talked about nearing graduation app contrib. So I think it's a really great project to be part of and to build awareness of Clojure in the larger deep learning community. So as MXNet grows, so do we. So again, we get to leverage a lot of the new stuff that's coming out of research and just be able to apply it. We just added an example that we'll take a minute and go through. It's state-of-the-art Bert, which is this bidirectional language processing. So it's state-of-the-art with text. And just it came out like in the last couple of days was a state-of-the-art facial recognition. And I'll show you this. This is retinal single-stage dense face localization in the wild. So this just came out like a few days ago. And this is the cool thing. I haven't had time to do this yet, but you could recognize all these faces, so many faces, but it's got pre-trained models for MXNet just right in here. So we could, I haven't done this yet, but you can just suck it into the MXNet model and you could take advantage of all this like cutting edge state-of-the-art face detection. So that's kind of cool. All right. Oh, sorry, I wasn't looking at the thing. Can MXNet take advantage of GPU tensor units? So it does do GPU. And so there is a CPU version and a GPU version on Linux. There's only a CPU on Mac. So there's some work needs to be done to get the GPU working on that. And I don't know what RTX 20XX GPUs are. So maybe if you want to explain that, whoever, Alan. Or I could look it up later. Oh, those GPUs have hardware specific to tensor calculations. Oh, okay.
Excuse me, are you talking about TPUs maybe? Okay, he's talking about TPUs actually.
Oh, he's talking about TPUs.
Tensor processing units.
Oh, okay. Yeah, I don't think it can take advantage of TPUs. It's only GPU. So.
I guess that only TensorFlow can do that right now. Also because TPUs are not really available to everyone.
Yeah, I think so.
Correct. At the moment.
TVM, which is some of the underlying structure behind MXNet, absolutely has an architecture that can take advantage of TPUs.
Okay, thanks, Chris.
So if you just read some of the documentation on TVM, it's possible. So my guess is that MXNet does. I don't know for sure. I haven't tried.
Yeah, I haven't heard of this being used. Like I said, it doesn't mean that it can't be used, but there might be like some tweaking or something to have it do. I don't know. I haven't played with it, so maybe. All right. Well, let's see demos then, eh? Let me turn this on. Okay, so I have an example of Bert that is just in master. Bert is at text processing. So the first thing I'm going to show you is this, I think it's pronounced squad. It's one of these things, you know, like when you always read these papers, you have really no idea how stuff is pronounced, but I think it's squad. So we're going to do Bert question and answering. So there's this squad data set that, let me, so you can get like a flavor of what this is here. Okay. So if you go into like this computational complexity theory answering data set, you'll have this like paragraph that'll say about complexity theory, blah, 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 blah. And then you'll have some questions that are based on this and actually trying to get an answer out of it. So, you know, what is the term for a task that generally lends itself from this? You know, there's the answer. So they have all sorts of areas where you can ask about this. It's Normans, like the rainforest. You know, how many square kilometers are covered in the rainforest? You know, how many nations control this region? It's really comprehensive, and it's stuff that I look at and went, you know, there's no way a computer could do this. But we're there. We're at that point. So this takes some a Bert, which is a Bert model that has been fine-tuned on this squad question answering set. Those weights have been exported. So we're going to be doing inference on this pre-trained system. So I'm just going to run.
Okay, sorry, Carin, while you're running the REPL, Mark Engelberg was asking a question about interrupt with Scala, but I think you're going to answer it with your demo, actually.
Yeah, so the Scala bits are hidden. They're underneath. So you shouldn't be dealing with Scala bits unless you're really developing the package. So I'll show some code for this so you can see what it looks like. But I'll show you the results first, right? You need to see the cake. So this is stuff kind of directly from the squad. You know, in a 1960s series discovering the most important information of the seafloor spreading, blah, 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 blah. But the input question that was put into this was, what was the most important question? And this was the ground truth answer, and it worked. It got the predicted answer. And then even though it wasn't, you know, trained on this, I just put in my own questions and answers just for fun. So, you know, here's my answer. You know, Susan had a cat named Sammy when she lived in the greenhouse. And my input question was, what was Susan's cat name? And it says Sammy. So that was just totally inference. It wasn't trained on that at all. So this is another one that I just made up. Well, actually, I didn't make it up because I think I took it maybe from the Wikipedia or something like that about the creator of the Clojure language. So I asked it, like, who created Clojure? And it predicted Rich. So very cool stuff. So yeah, so what does the code look like for this? Let's have a look. Examples, source. This is in the infer, and then I've got to remember how to make my text big again. No. Control X. There we go. Do that one more time. Okay, so like I said, even though underneath we are using the Scala stuff, you won't see that in your normal day-to-day stuff. If you're doing some new development where you're doing some new interop, bringing in some new functionality, we'll have to deal with that. And I can show you exactly what that entails. But this looks pretty much like just your regular Clojure stuff. You have some pre-processing, you've got your infer, you've got your main. So that all looks Clojure. So where is the Scala stuff? So the Scala stuff, and we're going to go back to the source package here. Oops. The interrupt stuff, we try to keep all in this, like util stuff. So whenever you need it, you can use it to transfer stuff to like maps and convert tuples, you know, vectors, convert vectors to immutable lists. It's really not that bad. So kind of keep all the interop stuff in there. And then if you need to use it and call it, for example, in module. So like creating a new module, you're going to have to, you know, do some data structure interop going in and out. So that's just what it is. So not too bad, I think. Okay, next example. Next example I wanted to do is actually I made, where we made a fine tuning, and the fine tuning, this was like super exciting to me because we were able to take this Gluon NLP. So Gluon is a, we support right now in the Clojure package, we support the module API. There's a module API and then there's a Gluon API. So the Gluon API is just another way to do the deep learning that's a little bit more friendly. And the Python has it, so we need to build that out too. But this is another project called Gluon NLP that specializes in NLP. And they have this nice tutorial that was like fine sentence pair classification. It was Bert. So we were able to take this and pretty much reproduce it exactly. And in a notebook format too, because we can. And if I can get it running, I will do it for you. So I use the Clojure. No, I'm going to get the thing wrong, so I'm going to look in the README. That's why you always have to write good readies so you can go back to it. Okay, so here it is. So this is running the notebook walkthrough. So you can run it, or you can do the Line Jupyter plugin. So the first time you use it, you have to do the Line Jupyter install kernel. But after that, you should be able to do Line Jupyter notebook. Line Jupyter. If I can type notebook. And this does have some funniness with Cider, which I have installed. So I think yes, I do mean that. So if you run into any problems, you might have to disable your Cider while you're running this. I think the dependencies in the Line Jupyter plugin need to be updated. So here is the fine-tune Bert. And you'll see that the kernel's starting and it's line Clojure. So the line Clojure plugin, this kind of got me as well. But if you just use a regular Clojure plugin, it won't use your line again dependencies. But if you use the line Clojure, it does pick up the dependencies, which is what you want. So the kernel's ready now. Mm-hmm.
Can you zoom a little bit?
Yeah. I think. Let me see. How's that? Better?
Oh, okay. I think this is fine for everyone. Thank you.
Okay. So this is a tutorial. It's based off of it. So here are all the namespaces that you need. So we're going to go ahead and run this. So we're going to load up the pre-trained Bert model. So you'd have to, I've already downloaded these scripts. I'm not going to make you wait for that. So if you run get Bert data, the preloaded weights will be loaded up for you, or will be exported for you. So you can just load the pre-trained model. So I like this picture, and you can look at this all a little bit later at your convenience. So it kind of shows you the Bert model architecture for the sentence pair classification. And you can go ahead and load it up, with the vocab and a set sequence length of 128. And here is the Bert base. This is when we're loading up this load checkpoint is actually loading up the pre-trained model right here. Okay, so now that we've loaded up the Bert model, the only thing you need to do after that is just like regular fine tuning. You need to attach an additional layer for the classification. So what we're going to do here is we're going to create a fine-tune model from it that is going to take it in, and it's going to add in a dropout fully connected layer, and it's going to create an output layer softmax for a classification at the end. So we're going to have our two number of classes for our classification that we're going to do. And I'll show that a little bit more with the data, it'll make more sense. So data preprocessing is always kind of huge in these sort of things. So it's using the Microsoft Research Paraphrase corpus data set. So if you download it, you can look at the top of it. It's got these columns. They're separated by tabs. The first column is a label indicating whether the sentences are semantically equivalent. We have the idea of the first sentence in the sample, the idea of the second sentence, and the content of the first sentence, or the content. Anyway, I can't speak, but it's always better seeing an example. So the ones that we're interested in is we're interested in sentence A, which is, he said the food service pie business doesn't fit the company's long-term growth strategy. Sentence B, which is the food pie business does not fit our long-term growth strategy, and whether it's equivalent or not. Are the two sentences equivalent or not? So if they are equivalent, then it's going to be a 1, and if it's not equivalent, it's going to be a 0. So there's a little bit about like token embeddings and position embeddings with Bert, which I'm not going to go into, so you can kind of go through, walk through this and read it. But then you do pre-processing to get all this text in the right padding and everything to go into the input model. The notebook is available. The notebook, so if you're looking at it, you go to, I'll put this in the link. This is actually right here in examples, Bert. And if you can't run, the notebook is right here. If you can't run the notebook for some reason, I exported it to Markdown, so you can just look at it in Markdown as well. So back to here. So yeah, so you do the pre-processing. At the end, you have some training counts, and you have these tokens for padding and for separation, and you have the token IDs and all the inputs that it's supposed to be to have the Bert model accept it, and the input batches for each rows. So at this point, we need to actually put it in ND array form, because ND arrays are how MXNet puts it. So we have to kind of slice it up into kind of three parts for this stuff, the prepared data. We have batch size of 32, and then we kind of construct it all, and we make this iterator out of it, this MXIOND iterator. So at the end, you have an ND array iterator. And so the ND array iterator, let's talk about a little bit what that does. This iterator helps as it's training. It helps cycle through things, batch it, and shuffle it if it's appropriate, and just manage your data in a performant way. So that's what the ND array iterator does. Okay, so now we're at the point that we put it all together. I'm only going to run it for one epoch because we have other things we want to do with our time. But it puts it all together. You make a fine-tune module And you can give it context. I'm running it on CPU, which I think is pretty amazing that I can run this on my CPU. You can run it on GPU. You can run it on multiple GPUs if you wanted to. And you can just run fit on it. And it takes the pre-trained arg params and aux params. And here's your optimizer. And it uses a callback. The callback, you can adjust the callback size to. I'm just putting it to 1 because I like to see its progress because I am running on my CPU and it's kind of slow. I mean, just generally. It's amazing that I can run it at all, is I guess my point. But so I'll just let this go for, just so you can see some output beginning, and then we can kind of open it up to discussions. Since I was planning 30 minutes and then I got talking and then I just go past that. So, and again, I'm running Zoom and this at the same time, so it may take a little bit. So maybe we should talk as it's going. Maybe I'll just make a change there.
Yeah, I guess it's okay. Thank you very much. It was really interesting. Does someone?
Oh, see, there you go. It did a little bit, so, but it'll keep going, so we can talk.
Yeah, we can see accuracy improving live. Great. Let's hope so, actually. Okay, so the floor is open for questions. Does someone have any question? Otherwise, I have some, actually. Okay, I think I'll start right away. So I was getting to know MXNet in the last few days because I probably need it at work. And I noticed that it's really, really easy to install. Actually, I think it's much easier than TensorFlow, especially the GPU.
That's amazing to hear. That's good.
I was positively impressed by this, actually, because I started using TensorFlow, I don't know, like 3 years ago. So it was pretty crazy to install back then and to get it to work afterwards. And I would like to know if then later someone would like to talk about their experience with some of these frameworks, if they have actually some deep learning stuff in production. And then what I wanted to ask you is, what would you say to someone who uses TensorFlow or PyTorch and you would like them to try MXNet? And why is it better, in your opinion, than the other frameworks? Of course, you already said something like this at the beginning, but I would like you to improve on that concept a little bit.
Sure. Well, from just a framework setting, just talking about nothing with the language itself.
Yeah, of course.
So MXNet has the performance. It's the most performant framework out there. I think it also, depending on what you value, I think having it be Apache open source is important, because that means that if you want to get involved, if you want to drive where it goes and make sure that it meets your need, you can have a say and you can help steer it in the direction that you need to. And in other packages that might not be the case because they are not Apache. You know, they don't have that ethos. And far from the actual language, this is, if you want to use Clojure, you know, this is, out of the three, this is the one that you can use with Clojure. And I think if you want to use it on AWS, this is a great fit for that as well. So did that answer your question?
Yeah, absolutely. That answered it. And by starting to use it, actually, it felt like there were less bells and whistles than TensorFlow, let's say. I'm not very used to PyTorch, so I can say about that. I can talk about that. But then it felt much leaner and much smoother than TensorFlow. But this might also be because I actually lately came to a TensorFlow, so I might be biased in that. I don't know. And I see that there are already a few questions in the chat. Okay, Mark Engelberg asks if most industry uses pre-established models.
So that's a good question. I don't think there's been like a survey on like what industries are using, but I would posit that the paths of the least resistance is taking a good pre-trained model and then fine-tuning it, because to get these like state-of-the-art models that are like really good, you really need to be a big company to have like all the data to really get big GAN, or like to train Bert, or to train you know, the OpenAI GPT. I mean, it's just incredible amount of resources that I think if you're going to do any real task, just starting from scratch and trying to get all the data out there on the internet is going to be not a very good use of your resources. I would say the best use of your resources is taking something that's out there that's state of the art, and then fine tuning it to your data set.
Okay, there's other questions. Okay, if Dwayne Jones asks about the experience productionizing these models, were you asking this to Carin specifically? I guess so.
Right, right. So we are working on putting it into production, but it's not quite in production yet. So I don't know how much I can speak about this, maybe other people, but I've heard lots of people talk about the challenges of getting pipelines together and, you know, making sure that your accuracy, you know, is measured over time. So I think again, this is an area where, you know, you have the research and then you have industry. I think industry is really going to start picking up the slack and learning how the best practices of building these pipelines and productionizing this. And I think that having the JVM and having MXNet are some good tools to do this. So I don't have the answer on this, but I think it's evolving.
And then questions about the Scala interop.
All right. Do most problems you run across with using this involve the Scala layer? I would think that it's mainly figuring out your models. But saying that, I mean, you do have, this is one disadvantage of running this high up on the stack, right? Because there are 3 different layers of debugging that, you know, you have the error that could occur in the Clojure layer, it could occur in the Scala layer, and it could occur in the C layer. So there are three possible areas that it could occur in. In practice, you know, I see most of my debugging time is either, you know, in the normal Clojure errors I usually make, or trying to get the models right in the layers. And when you have like a layer mismatch, it will complain at you at the C level. You'll get a stack trace in Java, but it's from the C level interop that'll say, you have a layer mismatch. You had like 31, you know, layers coming in here, and I was expecting 103, and you're like, where did I go wrong? You know, so. But if you're using pre-trained models and you're just doing like inference, you're not really going to run into any of that.
Okay.
Web behavior experience, Scala interop. Oh, I think I kind of went into that.
Yeah.
But the Scala interop. So I didn't know any Scala at first, going into this project, and I got pretty proficient at, kind of going back and forth, trying to. So now I could translate a Scala example to a Clojure example, and it really isn't that bad. I mean, it's like like I said, you don't have to do that if you don't want to. It's only if you're doing the development on that layer where I'm like, okay, Scala's built this new thing out. I want to wrap it, and I want to replicate the whole example that they do. That you would get into that.
Okay. Are there any other questions? Of course, if you want, you can just speak. It's free for everyone.
I have a question. This is Chris.
Yeah.
I was curious, there was some discussion somewhere else about somebody using different language models for different languages. And I researched Bert and Gluon a little bit, but not much. But Carin, for instance, if you had a bunch of documents in Italian, could you run that same fine tuning?
I think there is a different language model for it. So I think you would do a different pre-trained language. I'd have to do some quick research on that, but I think it depends on the corpus that it's trained on as well.
Mm-hmm.
So this is trained on like, English based. MXNet is actually very big in China. It's like huge in China. So if you're doing any Chinese stuff, it's going to have a lot of pre-trained stuff for that. For other languages, I'm not sure, but yeah, I don't know the answer to that. You have to do some research on it.
Yep.
Yeah, I can actually add something about the Italian language. I'm Italian. I'm working on Italian stuff. It's really difficult to find stuff that works in Italian because we are the only ones in the world speaking it. So it can get pretty tough to find accurate stuff. And Daniel is asking about the future goals of the project.
Yeah, that's a great question. So future goals are to get more people involved, to grow our committers. So that's one goal. To graduate out of the contrib. So that's another goal. We also have a couple of initiatives, and I can give you the link later, but there's like a wiki for the Apache, and anybody that has proposals that you want to do like a new thing, you just kind of post there and people give you feedback on it before you, it's basically a place to give your design documents. So one of the things that's in progress is a new API for ND array, and I can show you a little bit of it. It's so much better. So we're just kind of building that out. And this actually goes a little bit closer to the metal. Instead of wrapping the already generated ND array functions, I can show you the difference. It's hard to Clojure package or and then org. There's a gen directory. So the original one that we're mostly using kind of looks like this. You can use this if you know what you're doing and you look at the docs. So if you look at how to use some of this stuff, array test, we'll find a good function for you. So where's a good one? Well, here's some. So like here's powers. So you can do power, and it takes in like a scalar, and then it also takes in an ND array, or it can take in like 2 ND arrays. So you kind of need to know what you're doing here. And I'll show you the new API, which is much nicer. So look at this. Check that out. Look at like the doc strings and everything. So these are all taken from the underlying C API and generating the functions from that. So you're going to get a lot of doc strings to tell you what it's doing. You're going to get keys that tell you what the options are. So it's really just a fantastic. So we're still using the Scala package and like the JNI functions, but we're talking directly to the JNI functions at this point and being able to generate the functions the way that we want to. So this is the kind of the direction that we're kind of moving in. We're maybe taking it down a little bit. We're still only having, the Scala package be our main interface into the JNI. So that's one initiative. Another initiative is building out the Gluon API in Clojure. And that's a bigger project, but it has some interesting points. And I'm going to bring this up. I don't know if anybody on the call is really excited about this, but I know at least one person I was talking to is excited about it. But there's autograd, like, there's like, you could do autograd potentially with just like any given function because it's got a C API. So maybe that's something that we can leverage. It's also got a model zoo. Let me show you everything that it's got here. Actually, I could look at this. Gluon. Oops. Oh, this is the other thing. So if we get the Gluon API, we can just make our examples like directly match all these, like these exercises. So we could basically do a version of this book, but with all the Clojure examples, which would be super cool. So that is one thing that we're looking into. So that's a bigger project as well. So if anybody's interested in like building out another API and maybe eventually getting this stuff together, Model Zoo, MXNet. So that's not quite what I was looking for. I was looking for the Gluon Model Zoo. Anyway, they changed this around. So I don't want to look for it on here, but anyway, there's a whole pre-trained like Model Zoo that you can get to for the Gluon stuff that makes it really easy. So I think building out the Gluon API to making it a lot easier for users to use, build parity with the Python package, and be able to leverage all the documentation that they built in books. I think that's a good way to go. There's, I think, another area that matches up with our strengths as industry and Clojurists would be to also focus on the text aspects of it, because in most businesses, you've got tons of text or documents or something sitting around. So I think the opportunity for using deep learning in an industry setting, using text is much higher than using images. So.
Other questions? Dwayne Jones is asking if other major companies are supporting MXNet besides Amazon.
So there are a lot of, so AWS is one of the main ones. There are other companies, it's not just AWS. There's like NVIDIA is working with them. Intel also is a big contributor to the package, as well as Wolfram. So there's a lot of companies involved in helping develop it.
Okay, Alan Moore is asking if the training inference data comes from files and not via interop.
Yes, that is correct. It's from data.
Did you showed us an interactive example at one point where I thought you typed in a quote by Rich and then who invented Clojure. I thought that was an interactive example.
Yes, the actual training.
In that case, you were inferring.
Okay. I guess I'm confused of what you're talking about. The question is if the data is coming from somehow from Scala, and instead of from the pure data. Is that what you were asking, or no? Is that?
Sorry, yes, I was just concerned that if you're training over lots of data, you're going over the interop may be a bottleneck, and so I was hoping that most of the data goes for the training through other means besides interop.
Yeah. So the way that the training data is packaged, it's packaged in these iterators, but it's mainly on the C side that it kind of like packs it down. So I haven't done any benchmarks for Clojure, but they have done some for Java, the Java inference side. So there's the Scala is the main player for the JNI amp drop, and they've built out some Java API. It's only partial to use with the Scala to use directly with the Java user, and they have done benchmarks on that. And the time for the conversion of the data structures is insignificant compared to the actual core time that it's doing the work on the C level. So I would expect that it would be the same, that the overhead with the translation between the data structures is insignificant to the real work time.
Okay, Maxwell is asking if we need Scala interop to construct ND arrays used by the native code.
Right. Okay. So that's a good question.
Oh, okay.
Okay. So yes, the Scala interop is needed for the ND arrays. The JNI code is expecting those Scala data structures to translate the ND array code. So yes, you do need the Scala interop. Would it be possible to extend the core matrix protocols to support the ND arrays as a core matrix implementation? I don't know. Maybe. I haven't really looked at extending core matrix protocols, but maybe you could try it. I don't know.
Yeah, so just that there are a bunch of different backends for core.matrix, so that's what so it's definitely designed for that. I'm not sure what the details for the implementation would be when doing this with Scala interop, but just an idea.
Yeah, I guess as a back-end standpoint, you can't just get ND arrays alone. You know what I mean? It's like that would be a big fat back end because that's going to be like a whole deep learning framework as a back end. So I don't know. I don't know if that's a good fit or not.
Well, at the math level, probably your best fit would be TVM.
Yes.
Okay, are there any other questions? If not, I have another one actually. So let's say that there's a beginner who would like to think about deep learning, and we would like to point him towards MXNet and Clojure, of course. What do you think or feel, or if you think that nothing is missing, that is missing for people to actually be able to start learning about deep learning and Clojure at the same time in the most effortless way possible?
I would say there's kind of two ways you can go about it. You could go about it with using like a virtual machine, or you could try installing it locally and running it on your machine. So it does take some native dependencies. So, you know, like OpenCV, you kind of like need that installed, and other things. So I think when I've talked to people where they've run into roadblocks on trying to run it locally, they've run into some trouble with the native dependencies. So once you get past that, I think it's pretty good. I'll show you what you need to do to get going on it. So what I would do is kind of clone the MXNet repo. The jars are out there, so you can grab an older release if you want to from, or one of the releases from Maven. They're out there as well. But I find it convenient to just clone the whole repo, and then you have like all the examples right there. So, so this is an area I wish I could like improve a little bit. Maybe we can make it a little bit more dynamic. There's always like a jar. There's a jar for the CPU for Linux. There's a jar for the GPU for Linux, and then there's a jar for the OS X. And I'll just give a warning too that if you're running not an Ubuntu or like a standard Linux, some of the I forget the name of one, I don't even remember. Some Arch Linux, I think it was. There's some rough bumps in trying to get it to run like an Arch. But if you're running on Ubuntu, it seems like it's pretty good. So what you would go in here, and I usually find the easiest thing to do is just pull down. The Scala package does like a nightly snapshot, which is great. So you can just like pull master, get the nightly snapshot, uncomment what your configuration is. I'm on OS X CPU. You know, I'm running the snapshot for 150. What you're going to do is like comment out the CI one, so you're not pulling that one. And you just kind of go from there and do like line test, line install, and then you can run into CD into any examples and run all the examples. There's like a tutorial example. Oops. That you know, goes through ND arrays, symbols, and module. So it'll walk you through the MNIST and how to construct layers, and you know, kind of point you to how to do everything. So I think that's kind of a useful way to start. Just looking at the other examples that are out there. Yeah, there's a Bert one. There's one on fine tuning, CNN text classification, CAPTCHAs. You know, there's a whole bunch out there that you can come play with. Oh, there's also a great. This is really good. Arthur Caillou just made a bunch of blogs about this. MX Made Easy. So actually, this is a really good way. Oops. Oh, wow. I guess I gotta do Clojure. There we go. Oh, made simple, not easy. So he's got a great blog series. You can go there and go to the root. Oops. But, you know, getting started, and actually this is a really good path to do, because you could get started on AWS and then you don't have to worry about all your local stuff, or you can try to run it locally, and it goes from ND array, symbol, module, the visualization of symbol using OpenCV, and then some pre-trained models. So those are great series to go through. I'll put that in here as well.
Okay, great. Dwayne was asking, I think that D2L.ie was the book you were showing earlier, right?
Oh, I think so. Yeah, dive into deep learning. It is. So these are all people working on the MXNet.
And this is the Gluon API, right?
MXNet encompasses the Gluon API. So there's so there's a Gluon API and the module API. But I've looked through some of this. Oops, I'm clicking. Some of it so you can use just as is. It's not all Gluon, but so if you look at the exercises in here, this ND array stuff you could probably do verbatim. Can't do automatic differentiation yet, but a lot of it you could probably get pretty far in.
Okay, great. Some other questions?
So there's a bug. Last time I checked, there was a bug in the database for the Scala bindings that they were actually considering moving to JNA, and or at least some dynamic system, which would eliminate quite a bit of their build steps and some of their dependencies. Which, for instance, OpenCV is something lots of people have at lots of different versions, and I don't want to commit anybody to the Scala version that they decided to use on that month or whatever. So this isn't such a question, but we've talked about this before. What's the best way to start working with the Scala team to raise some of these issues? Like for right now, I can't easily use TVM with MXNet because I have to guess which shared library is actually unpacked on the system because the C bindings aren't actually exposed through the JNI layer for TVM, even though they are all there because MXNet does use all of TVM, the compiler facilities and everything. So there's like significant functionality exposed in the MXNet shared library that is difficult to get through because Scala team built their own shared library that then wraps it. Does that make sense?
Some of it.
Yeah, maybe that's a bug there.
But I can speak to the best way, because the Scala team is very interested in looking for feedback, and this is your Apache open source way of working. So mailing lists are used an awful lot. So I would suggest to join the MXNet mailing list, and putting your experience and where you'd be willing to contribute, right? And asking like what is the best way that you could move forward. They'll most likely say, you have some opinions on it, say maybe, make a proposal on it on the wiki, so they can discuss it some more. And once you have a direction on that, and you're, generally it's like open source, right? I mean, generally they're much more receptive to something if you're going to put in the time and work to help make it there, right? If you say, I have this really great idea, I want you to spend 3 months and re-architect your system, they're going to say, well, that's very interesting. But, if you're willing to work with them and put in some time and code to make it better, that's, I think would be very well received.
Yes. Okay. Chris, were you thinking about doing this for integrating all your tech.ml stuff with MXNet as well?
Well, for sure. Right when I built the TVM stuff, there was actually tech.mxnet. And I briefly had I could basically load MXNet in and use TVM to like pre-process the images, for instance, going into the models, which is conceivable to need to do, especially if you're training and you want to have fancy augmentations of those images for some reason or another. And I just kind of did enough as a proof of concept to say like, oh, this is a little hairy, and they have a bug that would actually solve my problem, but I had enough other things going on that I didn't want to get into it. TVM is, to put it very briefly, TVM is a very advanced math and in-dimensional compilation substrate that you can use to program for CPUs, GPUs, or ASICs, potentially, in-dimensional type problems, such as a convolution layer of a neural net or a lot of image-based processing. I don't really want to go into it because I've already given a talk on that, and you can find that on the internet, and I can find a link to it. But it's TVM CLJ is a project that I built because I thought TVM was such a promising direction for the Clojure community and for the JVM in general, because it gives you really good, fast, correct arithmetic for unsigned numbers and for GPUs and things like that. You can use however you want.
Okay, thanks. So if no one else, okay. There are some questions. No. Okay, what if someone can speak actually and say if they're using MXNet or if they're using other data science stuff in Clojure, or if they would like to start using MXNet and what they're hoping to get out of it.
I've used MXNet, not from Clojure, to do facial recognition work. And I intend to use MXNet in the very near future to start writing some NLP examples in Clojure that show kind of different frameworks and that kind of thing.
That's great.
Yeah, if you run into any problems like using MXNet or just generally want some help, just letting you know in general, Cognitech is nice enough. Like I have 20% time, so they let me use my Fridays to devote to MXNet open source work. So if you grab me on a Friday, it's always a good time for me.
Awesome. I'll keep that in mind.
Okay.
Yeah, I think this is really nice because actually I think that this project might become the killer feature for Clojure, or the killer app for Clojure in some way, because it's a bridge. You can program in many languages in MXNet. Clojure is there, and so you can use Clojure to feed stuff in and get stuff out of MXNet, and that means that you can use the JVM. People that get stuff in production usually tend to like the JVM, so it's nice also for them. And I think this is a very important work. And what I think is missing probably is the part before, some things on the part before and some things on the part afterwards MXNet. So how do I get stuff in? How do I take stuff out and then serve it to someone or something else? It really depends what I'm doing with it. So for instance, I saw that there are a lot of examples online. Is there something about images as well that you can show, I don't know, very briefly? Maybe someone is working on that.
I could show an example with images. I'm not sure exactly what you're looking for, just the classic classification or?
Yeah, no, I meant also if you can show how you got the images in Clojure and then into MXNet in an efficient way.
Okay. So there's many ways to skin a cat. But I'll show you one way here in the pre-trained example. Oops, let's get this out of here. Yeah. So in the pre-trained models, there is, I think it's in the pre-trained models. Yeah, there's like a predict image. Well, I don't know whether I want to show you that or if they're the inference package, which makes it a little bit easier now. Okay, so there's like a low-level way of doing this, and then there's like a high-level way of doing this. So I guess I'll show you. Go through real quick. And I've got this thing that's in the way. Close that. Examples and then pre-trained models. So this is more kind of the low-level way of doing it. All right, so we're going to download ResNet, which I didn't download yet. So I guess we need to do that too. ResNet, what does it use? ResNet 152. Oh, this is going to be boring. Maybe it won't be so boring. So anyway, here's like a get image. So this is a low-level kind of get image. It's using OpenCV to get the matrix from the URL and convert it to some stuff. You're predicting it and getting stuff out. Maybe I won't show you this. But there's a higher level way of doing it now with this infer package. So there's like a, I guess like an object detector. So the object detector has a higher level way of doing things. So you have a detector and you can just have like load image paths. You can use like infer load image paths. There's like an infer load image. So there's a higher level way to get the images in and out. There's also now there is an image that doesn't rely on OpenCV at all, but it uses NDRay. And there's functions in here that allow you to decode an image. Actually, I guess it uses OpenCV in the underneath the covers, but you don't need to require it or anything like that. Deal with it directly. You can read an image, resize an image, apply borders. So there are some nice high levels ways of doing this. So convert an image, NDRay to image to a real image, draw bounding boxes, that sort of thing. So you can use the higher level functions as well. So you can use OpenCV directly or use the higher level stuff. Or the infer package where you just say load an image from a path and shove it in the inference.
Nice, thank you.
Okay.
Anyone else? Okay, we saw that you started the Jupyter notebook earlier, and I know that Daniel is actually working on something like that, but with our studio.
Oh, that'd be great. Yeah, because this is, you know, the dependencies are like old, and yeah, there's some rough spots. It'd be great if there was a good notebook.
Okay.
I've wondered why perhaps Clojure doesn't use pods or something like that. So the things running, the things actually running your code aren't interacting with the Clojure ecosystem very much. That's potentially way more in depth, but we have a couple texts that we use to like isolate running JVM sub instances. And right now I don't think that they're using those. Maybe that's a good discussion for them. Maybe it's not possible. I don't know. I'm not them.
And also iClojure that does something pretty different than Clojure. They use the REPL protocol to communicate with the server.
Yeah, I looked at using that, and I honestly, I would have probably preferred to use that, but the line plugin for this makes it so nice that you can use a one command thing. This is like install kernel, you know, that the other stuff is the tooling isn't there that you need to like, you know, do the git clone and like do a lot of work to install the kernel before you can actually really get going on it. So that's why I kind of chose to go this path, but I do like
Daniel, can you talk a bit maybe about what you're doing with your studio? If you can, if you're available right now.
Yeah, sure. Can you hear me okay?
Yeah?
Oh, yeah.
You're a little quiet.
Yeah. Oh, okay. So maybe I'll try to make it a bit better. So, is it better now?
Yep.
Maybe. Yeah. Thank you. Yeah. So in the last couple of weeks, what I've been doing under my employer is playing with R and Clojure together, and so I think for several of us, we have had several kinds of experience in connecting R to Clojure, mainly when we needed R from Clojure to consume R statistical functions and visualization functions. But now there was some other idea that I heard from our people. I talked with my CEO, Asaf, who was a Clojurian and now likes R. And I also talked with Alan Dipert, who is a Clojurian and is working in our studio nowadays. And they both said that it could be interesting to consume Clojure from R. And it is interesting for several reasons. One is that it could be interesting to our people who are really sometimes open-minded towards functional programming and Lisp ideas, and they could love it. And another reason is that then you can use Clojure from RStudio. So probably several people here know that RStudio is, for several years, probably the most popular IDE for R. And it is somehow, it is an interesting project. And one of the things that happened there was a very unique notebook experience, which uses Markdown as the main format for the notebook, but gives some interactive experience with Markdown. And it turns out that all this is very extensible, and it is very easy to use that as a general IDE for any language that you would like to use in those Markdown-based notebooks. And that is quite possible to use it with Clojure, and that is what we are doing. And we are hoping to release openly in the next few months. And there are some interesting questions there. Probably, would we use NREPL mainly, the NREPL protocol, as the main way to communicate between the IDE and Clojure? So there are many reasons to use NREPL, but for some kinds of interop, it may be slower than other options. So like JNI, for example. So that is where we are standing. We're trying to see what would be the efficient ways, and there are some interesting questions about the type systems, communicating all the Clojure types with the R types. And so that is why it is a bit challenging to make it right. But it is going to happen. And then I think we'll have another option for a notebook experience in Clojure. Does it make sense?
Yeah, that sounds cool.
Yeah, I
so,
think.
sorry,
Go on.
No.
Okay. I think that's really, really nice, because as we were discussing it a few days ago, and I was thinking that getting to Clojure, R programmers is going to be much easier than Python programmers, because R is much more Lisp-y than Python actually. And so it's really, really cool in my opinion. And then I started programming with R, so to me RStudio, it's a really nice IDE, and it would be really great because you might have plotting on one side and all of this tooling, nice tooling already done for you, which would be really, really cool. So anyone else have a few questions for Carin, for Daniel? No? Okay.
So
there's someone?
If I may suggest, maybe we have like a little bit more time till the end of the meeting, and so it is a good opportunity for people to talk about what they have been doing or what they have been interested in. And I guess many people here are studying something or have some beginning of project, so it's a nice time that we could talk about it if anyone wants to.
Yeah, I can talk a little bit about what I've been working on. This is Chris Small here, and I've been working on a Oz, which is a data visualization library wrapping Vega and Vega Lite. And I'm sure I've talked about this with a bunch of you, and John Anthony, who's here as well, is working on sort of a similar project. The thing lately that I've been working on, which is kind of news, is some static site generating features. So one of the things that has been happening with Oz lately is I think where it kind of shines is in dealing not just with one-off visualizations or sort of say widgets or interactive panels or whatever, but kind of thinking more about like, how do we utilize data visualizations and scientific content from documents and sort of stitch those things together. And so as I move sort of further out, I've realized that it's, this is kind of the direction things are heading, that having sort of static site generation features would be a really helpful thing. We have a couple of static site generation toolkits in Clojure, which I think do a good job of what they do. But having something that was kind of pre-baked with the ability to layer in Vega and Vega Lite visualizations, it would, as well as other kind of scientific content, LaTeX, whatever, would would sort of, branch out in this direction of, not just taking results and sort of exploring them and doing something with them, but actually, taking them the next step and really sharing them with the world. And so the sort of fun side of that is that recently when Ariel gave his talk about data science and over at Amperity, and sort of went into this idea of a sort of like fig wheel-like experience for data science, sort of like a fig wheel-like notebook kind of thing. I went ahead and sort of took a stab at this because I thought it was an interesting sort of problem, and built this sort of live code reloading functionality, which looks at your Clojure code and sort of evaluates only those forms which have sort of changed from the last time you ran it. And what that sort of lets you do is if you have sort of a bunch of code in a file where, it almost sort of starts to look like a REPL, right? Where like, I don't know how a lot of you sort of do your workflows, but often when I'm doing kind of like REPL development, what I actually want to do is like write that code in my editor so that I have, all my sort of editor features set up. But then I want to run it in a REPL. And where things get tricky is where you have sort of steps in your sort of REPL flow that take a long time to run, which obviously happens a lot if you're doing kind of data science-y sort of stuff. Even if it's just kind of some basic data processing, maybe downloading some data or whatever. Sometimes that can be something that you sort of have to start working around. And you start doing things like, okay, well maybe I'll put that in def once or whatever, but then you need to update it because something before that updated. Now like, oh gosh, I have to go. There's this whole sort of state problem, right? And so just sort of simplifying that problem a little bit with this execution model, which only evaluates forms that have changed, is sort of an interesting. Realize I've been looking at a different screen here. Sort of an interesting approach to the problem, and it's not perfect. There's definitely some stuff to do there to make it sort of more general, but I've been finding it really useful just for kind of hacking around at sort of like REPL programming, and that again, kind of stitching these ideas together. I had the notion that if we're going to be going and doing all these sort of static site generation features, wouldn't it be nice if we're also getting all of this sort of live code reloading and live visualization reloading and sort of stitching it all together so that if you're working on a bunch of say Markdown files with data visualizations, or these Clojure files which are sort of at the very end emitting a document which might contain data visualizations, that all of this can be both compiling to static assets, which you can serve super easily just using AWS, or I don't know if you know Surge, but it's a great little command line utility for publishing static sites. But also, like, as you change files, it's popping up the latest sort of thing that you edited. So you start editing one file, and as soon as you save it, boom, you see those changes. Then you start editing another file, and boom, you see those changes. So it's still, I'm like, it just kind of finished this like last couple of days, so it's kind of fun to talk about it here. But I'm excited to push it up and see what folks think about it. Because so far, again, still a little bit rough, but it's sort of an exciting direction, and yeah, I'm interested in seeing what folks think of it.
Thanks. It sounds really cool.
Yeah, thank you. Yeah, hopefully it's as cool as it sounds.
Yeah, it seems pretty cool, but what about all the processing? I mean, if the function that changes is a very heavy function, so it has to calculate all the stuff.
You mean in sort of the incremental, or the, what I don't know how I call it, but the live code reloading?
Yeah.
Yeah, exactly. So that's where this kind of custom execution model comes in. What it does is it uses Clojure Reader to read in the code as data. Or, well, let's see, how do I actually use it? Maybe I might just be using Eden Reader, I forget now. No, I must be using Clojure Reader because you need it for literals. So, so yeah, right, we just use the reader to read in the code as data. And then we effectively, like, each time the file changes, we sort of cache like, okay, what's the current, again, sort of not counting like white space changes or comments or anything, but just like once we, read in the code as, as data, where's the first change? And we only actually run from that first change. So, if the first chunk of your file is a bunch of like downloading data and then like maybe running, MXNet or whatever, and then down below that, okay, now show me a visualization and do some summary statistics and, maybe a table of the results or whatever, right? If I go and I update just something in the visualization, that's only stuff from there on after is going to need to be recomputed. So everything before that's just going to stay there. And again, it's just in a live coding sort of environment where, just save the file and boom, things update.
That's really nice.
Yeah.
Okay, go on. Sorry.
Yeah, one quick thing I'll add is in relation to our Markdown, which is really cool. And I didn't even realize this actually initially getting into it until I kind of started deciding how I was going to do the Markdown functionality they have, which is right, like you can get a Markdown document and in one of the code blocks, you can add a class that says like, this is Vega, and that will then tell it like, I want you to not just interpret this as, not just render this that is as like JSON or Eden, whatever it might be, but I also want you to now go and evaluate it as a Vega or Vega Lite visualization. So it turns out that strategy for embedding stuff in Markdown is very similar to what our notebook does. And so as far as, and I think it's actually pretty similar to what Next Journal is doing, if I'm not mistaken. So yeah, in any case, there's kind of this interesting convergence there and this pattern of, sort of extending Markdown documents with sort of extra functionality, which I haven't even really fully plumbed it yet. I mean, right now it's just for visualizing, these Vega or Vega Lite visualizations. But I think the next step is going to be to also say like, sure, if most of what you're doing is just laying out a Markdown document, but you want to include a little bit of code that actually dynamically generates data visualization or whatever, then you can include that in there as well. So yeah, still sort of plumbing the model, but it's promising, I think, and cool.
Yeah, that's a sweet spot. I agree.
Yeah. Yeah, and it's nice to see that like it's not just me that's doing this. It's sort of like, oh, this is kind of a pattern that's sort of emerging in how we use Markdown, which is great.
The floor is open for anyone for questions or anything else.
So I'm going to say I've also been working on rebuilding a lot of the base infrastructure behind the TechML subsystem. And I did a lot of research into APL and numeric programming languages like APL and J, and basically built out a graduated pathway from using persistent vectors to doing APL style y-dimensional arithmetic kind of on anything you want. And so it's basically, it's works from a concept of a reader, which is an index. Given an index, I can give you a value. So it's randomly accessible memory as opposed to a sequence, which is linearly accessible memory. And if I have randomly accessible memory, then there are, in fact, a lot of things that come with that, and there's a whole different style of computing based on producing indexes, which you would normally not do if you only had sequentially accessible memory. Anyway, I built out this pathway to remove the tech.compute dependency from the data type library and from TechML, and to make it a lot easier to bind sophisticated kind of functional math capabilities into other things. So when you say like one vector plus another vector, the result that it gives you back is a lazy functional data structure. It doesn't evaluate that operation and produce a new persistent vector or a new Java array or anything like that. It produces a new reader that when it reads from index Y, does the actual operation in line. And so this allows me to build long chains of these operations, but not have anything execute in a lazy way, in a Haskell lazy way. And then I can force execution by copying into the final thing that I actually do care about, which may be an image or it may be an ND array. In MXNet, it could be a lot of different things. So that's some of the basic stuff, but I've simplified and basically made TechML quite a bit faster executionally in terms of data set processing. And that's it.
That's cool. Are you gonna like do a blog or something on like maybe an example? I know that's always hard to document instead of do, but I think that would be really cool to have like a kind of walkthrough.
Yeah, I do have an in-depth technical walkthrough on tech.dataset or tech.datatype, sorry, that starts from the very beginning of sequences and ends with n-dimensional tensors, and basically making an argument that this is how you can build like abstract algebras in Clojure arbitrarily. And so there is some documentation on that, and there's a cheat sheet, but I agree that talking about it more would be a very good idea. I've been really focused on working through NLP and what are all the NLP libraries out there. And I guess I feel like because TechML is at such a high level of abstraction above the data type library, getting a solid NLP example would enable more people to do machine learning at their jobs than me explaining too much more about data type, which is kind of plumbing.
I agree. NLP is pretty important for pragmatic reasons.
And yeah, you made a really good point, Carin, actually. I think most people who do, most of the TechML system is meant for people who just do Clojure. If you do Clojure and you have access to a database, you can do machine learning on it, for sure. Because you can always get a sequence of maps with keys in them, and you can do machine learning on a sequence of maps. That's the point behind TechML. And I agree, it's awesome that MXNet is going the NLP route, because I don't think many people have computer vision problems at work. I think that's a very, very small number of people, but most of the people who will listen to this podcast could use MXNet at their jobs to do a lot of the NLP stuff that you highlighted. And I think that is really neat.
Yeah, I want to get a hold of, and this is kind of cool too, because, you know, that's more cross-pollination. I actually did a PR in the Python Gluon NLP library to get the base Bert model exported so we could use it.
Mm-hmm.
And I want to get a hold of the GPT, if people know what GPT is. So this is the OpenAI model that they haven't even released. They've released some of the pre-trained rates, but they don't want to release the full pre-trained rates because it's too dangerous. Because it's just too good. Like it could generate text like unicorn levels. So they released they released the first cut, and then they've released just a few days ago. They've released the medium-sized pre-trained weights that they deem it's not too dangerous. But they still haven't released the really big one. But the steps to that would be, you know, that I would be looking at would be making another PR or helping along, get it in the Gluon NLP side so we can get the pre-trained weights to export it to then bring it into, you know, the MXNet proper. So it's a lot of cross team work, but it's cool stuff that would open up a lot of doors for us. And hopefully not be too dangerous.
Anyone else? Daniel, you're talking, but we're not hearing you.
Thank you. Thanks, Alan. So I'll just mention something that we were talking about the other day. It began in a discussion with Ethan, who is here. And Ethan told me that one problem that we have with working with data in Clojure is that many of us do not know about other people's sessions. We do not know actually how the workflow looks like. And you know, many of the people here in this discussion, I think, work alone or almost alone. And we would like to see more of how other people's working sessions look like. And what we thought about was to do some kind of interviews. You know, 2 or 3 people meeting in this kind of video discussion, and just one of them is showing the workflow, working with data, and the other people are asking questions, and then we may realize something, which is not best practices or any realization of what would be the perfect way, but more of realization of the problems that we have working with data. And so this is a call to everybody. If you wish to show your workflow, which is not the perfect one, but just any workflow, and or if you wish to join this kind of discussion, then let us do it. And we'll try it in all kinds of ways in the next few weeks, I guess. And since I guess these are maybe the last few minutes of the official meeting, then maybe we can tell a little bit more about the next upcoming meetings. So the next meeting will probably be in somewhere in June, and it will be about Next Journal with Martin Kavala. And afterwards, we are planning several meetings about data visualization with several of the people here who are in this meeting, and it is open for all kinds of other suggestions of if anybody here wants to show what they are about in this kind of video gathering, then let us do it. And
No one who wants to share their workflow? If you'd like to, I can share mine. But before, I would like to ask Christopher about what I wrote in the chat.
Oh yeah, let me. I sort of moved things around, so I missed that.
Yeah, no. I'm going to ask it.
Yeah, sure.
So everyone can hear. If it would make sense to persist the resulting computing graph and then using it to deploy the resulting pipeline, actually.
You mean like a compute graph?
Yep.
Yeah, so it's a sort of trivial compute graph in that, right? It's just sort of a sequential. So it's not doing anything intelligent as far as like figuring out dependencies between forms. That would be really cool. It's something I've thought about, and maybe you could probably, I sort of thought through this a little bit, and I think you could implement a sort of dummy version of it, which would probably get things wrong in certain circumstances. And, maybe you could find ways of patching that up here and there. But yeah, I mean, without more sort of assumption about state and purity, it's a little hard to know, like, given any chunk of code, what chunks of code following it might need to get rerun, right? Under some sort of simple assumptions, like, that you're mostly writing pure code, you can imagine, like, okay, well, I'll trace my my define forms and figure out which symbols I'm using where, and sort of assume, like, if I see one of these things update, then everything in between until the next time I see that thing update can maybe just stay the same, etc. I think that'd be really cool. But yeah, that's not what we have going on right now. Right now, you just have to assume that from wherever you make the first substantial change in code, everything after that's going to need to get rerun. So that's the model right now.
Great.
Yeah.
Cool. Thank you very much.
Yeah, you're welcome.
Okay, so if no one else wants to talk, I can talk about what I'm doing right now. Actually, I'm working on a system that takes some files from a cloud folder, and I have to take that, then read these files, which happen to be Excel files. So I'm working on a library to read arbitrary Excel files in Clojure. And it's pretty early to talk about it, actually, but I hope it's going to be released in the next few months, let's say. And so you can actually read and write Excel files. I know that there's already something like that, but I want it to be as efficient as possible, and it's at the same time have as much control as possible. So if you want to have a lot of control, you can have it. So you can use full-blown Apache POI propped out. Or if you want to do just open or write very huge Excel files, you can do that, but of course you're going to lose some information, mostly formatting, basically. And then after I take these files, I have to call an API, actually more than one, get data in, process this data, do a lot of financial calculations with this data, and then spit Excel files out. Of course, in the meantime, I want to actually persist all this information somewhere. And then I'm going to train some machine learning models on the stuff, actually pretty basic stuff. So mostly classification, binary classification, actually. And all of this, I'm trying to do it, everything in Clojure. Also because for the deploying stuff, we already have a Kubernetes cluster that can take any arbitrary jar and just run it inside the Docker file. So it's pretty nice. So I can do whatever I want, mostly. But what I'm finding that is pretty difficult is to have all the parts, because we have most of the parts actually in Clojure are there to do all of this work, but there's a lot of glue code to take them and put them together. So probably what we are making right now, it's a few bridges or someone that encodes a couple of workflows and says, this is what to do, and probably it's what others should do. So I don't know if this makes sense, actually.
Alan, I just want to say that what you told about writing Excel files sounds so useful, because Excel is, in some places, Excel is such a common format that is so accessible to everybody, and sometimes more than HTML, and in the sense that it gives power to the one who gets it. And so it can be a wonderful way to share your report or anything that you create. So I guess we are about the end of the official time of the meeting. So Alan, maybe you wish to conclude, because maybe some people need to go, but some of us can stay and chat if they wish.
Yeah, of course, for sure. I would like to thank you all for being here. It was very interesting. Thank you very much to Carin again.
Yeah, thanks for inviting me. I got some really good feedback, and I enjoy, sharing the work that everyone has done on the project and hope to get more people involved as contributors or users, just users. So, yeah, thanks.
Great, thank you very much. And of course, if some of you wants to stay a little bit more and keep discussing about some things, we can do that. But in the meantime, this is a wrap. So if you have to go, you can go. And I would like to remember you that this is going to be recorded. This is recorded, and it's going to be put on YouTube, so you won't lose anything. Okay. So goodbye to everyone who's leaving.
Yeah, I got to go, but just wanted to say again, thank you, Carin, for presenting, and thanks for everyone for sharing. And yeah, I look forward to the next meeting.
Thanks. Goodbye.
Bye.
Okay, someone wants to talk about anything else?
Yes, so I guess it could be interesting to think about what you mentioned about the compute graph of your workflow, because usually we think about these two things separately. We have our sequential flow of writing a notebook, because that is how notebooks look like. And then sometimes we need to do computation, and then sometimes we need to think about the computation as a graph where the parameters flow and everything is influenced by the parameters as it has to, more generally than a linear flow. But actually, why the separation, right? Maybe that is what you're saying, Alan, that we could somehow make the flow of writing enjoy the more general model of a graph and not the linear way of notebooks, right? Is that what you're saying?
Yeah, mostly. Actually, being able to do some stuff at a REPL or in a notebook or in what Chris is doing, and then having some sort of a data structure coming out of everything that I've done, or not maybe everything that I've done, because it's really likely that I did something stupid in the meantime. I might have opened the wrong file or something else, but only the important parts, getting them out in a data structure, which is mostly static, and I can put that under version control, and then I can have some kind of service that takes these data structures and then just runs them whenever you want. It would be really interesting.
And then it can be parameterized too, right? Then
yeah,
when you
course.
have it, yeah. Mm-hmm.
Yeah, of course. So you can put, I don't know, you just add, I would like to run it every day at midnight, and I don't know, maybe limit it to 2 CPUs, 2 cores, and all this sort of stuff, and it just runs.
Yeah.
This would be the dream of many data engineers around the world, actually.
Yeah, and then the question is how, right? How would the system figure out the graph of what you do, right? So one way could be code analysis, but it may be a bit tricky with macros and all that. And another way would be to wrap your values with a certain type that is aware when it is dereferenced, right? And then, like they do in the UI world, in the Clojure script libraries that do this kind of stuff, right? Yeah, let us play with that. Maybe we can try to build a toy that is an example of what you're saying, right?
Yeah, it would be very interesting. It would be really cool. It's difficult as hell, but it would be really, really cool. And I'm seeing that people are talking about iodide, I think. Do you want to say something about it, some of you?
Yeah, this is John, Anthony, and yeah, the thing is that the workflow with it is what struck me as the more interesting aspect. So, I mean, it's basically the idea is you have you have effectively just a standard editor. Let's say it's on the left part of your screen, and you have multiple markup capabilities. So you can mix different languages, standard markup, presumably stuff like LaTeX, whatever. And each of these little blocks then correspond to the renderings over on the right, which is the document. And as you change things, you can sort of, as you change things, stuff just automatically updates in the document. And of course, you can save this stuff and whatever. But the nice thing about it to me was you don't have the standard notebook modal cell, linear cell kind of stuff going on. It's much more the kind of work interaction is much more like what you do at the REPL. And but the neat thing is you can actually mix different languages together as well. So in their particular case, you can mix JavaScript and Python. So you can, and they actually manage to get, the weird thing about what they're doing is they do this by basically compiling everything into WebAssembly. So they literally take the Python interpreter, the C code, and compile it into WebAssembly, and then directly use it. So you actually have Python 3.7 or whatever running in the browser, and they did the same thing with NumPy and Scikit, I guess, and a couple other things, so that you can then load data sets. You can also load data sets using, I think there's another language too, and I can't. Oh, Julia. I think they have Julia working on it. Yeah, so I kind of liked the basic flow of that, because you don't have to have that enforced linear thing that you get in typical notebooks. And it just, when I saw it, it struck me that it was interesting also in that there was, these ideas are the same kind of ideas I was noodling around with in Scicloj. So there's this unreleased version of Scicloj that has all this live editors with that can be done where you can use client only, so it's just strictly Clojure script, so it's self-hosted, and or mixed with Clojure on the server. And I have a very preliminary thing where you can throw Python into the thing as well. So all in this, in the editor pane, you can do this, and then you can have Markdown and LaTeX and all that kind of stuff. And so it was strange in that it was a similar idea to this, to what the Mozilla Iodide people were doing.
Yeah, and if I'm not mistaken, it's JavaScript, but unfortunately, I didn't have time to actually delve in it. So I have no idea if it would be possible to actually get Clojure script to work in there in some way?
Oh yeah, yeah. Actually, I would tend to think that it would be really easy to do that. I guess they're open to the idea of including other languages and stuff as well. Mostly that they're thinking of as other languages like, I don't know, like the Julia or who knows what else, or maybe Go, who knows, where they're literally going to take the code for that, the source code for those things, the compilers and whatever, interpreters, and then just compile it all with using WebAssembly. And then literally have everything running in the browser. It's kind of that part strikes me as kind of maybe not the greatest idea that ever was. I mean, I sort of understand their rationale for it, but I'm not really convinced. But certainly since JavaScript works, that just works directly for them. And since ClojureScript just compiles to the JavaScript, I would tend to think that should be a very simple inclusion.
Great. Thanks.
Yeah, hey, Alan, just to answer your question, if you never messed with org Babel before, it's kind of like multi-language live coding. Just throw it, these code blocks in there, and then when you go to effectively compile your org document or render it, you get all the code interaction. It's more along the lines of the polyglot stuff, where you can kind of splice things in, and then some people have taken it and done some pretty kooky stuff with it. Not to the level that it looks like Iodide does. I just looking at Iodide. It's got some pretty impressive stuff in there. But again, it's all browser. It's browser centric and web based. So it's pretty cool what you can do with it. Just throwing it out there is another point. This org Babel stuff. Yeah, just real quick. Aside from all that, I just wanted to circle back on the stuff you were talking about, Alan, with your munging XL. So in my domain, that used to be the coin of the realm, and to a certain extent, it's still the baseline for a lot of folks. And so I interop with that a lot. I don't know what you're doing exactly, or if you've already built something. I've got a fork of some of the Doctor stuff in their XL Apache POI library interop that I forked off for performance reasons and patched some stuff up years ago. I never pushed it back to mainline. But one of the things that we ran into early on was generating and also consuming this stuff significantly, doing a lot, like either large books or doing it fast. And there was just some of the typing and coercion stuff that was in there was kind of running off the rails, like with dates and stuff. So just curious if you've already built something, I'd be curious to see what you've done, if it ties in with the Doctor stuff, or if it's Apache POI based or whatever. If you expand on that.
Yeah, thank you. No, actually, I was building it from Apache POI directly. I didn't know you had already done something about it. I'm surely trying it. And I was using FastXL reader and writer as well, which opens a stream, and then you can consume that stream. While with Apache POI, you just have to read everything at once. So of course, it's going to be much slower. Does it make sense to you?
Yeah, I'm tracking, man. That makes sense. The other thing I was going to mention along, because we're dealing with, like I said, there's a lot of Microsoft-based stuff. So PowerPoint is another natural one. We ended up having to generate lots and lots of PowerPoint. So we were generating visualizations programmatically, and then building up these, these presentations with hundreds of slides of just all sorts of visuals already put in there. So that ends up being non-trivial. There's the POI libraries are there, but you got to do a lot of wrapping. We've done some of that too. I need to clean it up, but it exists in one form or another in a publicly accessible way. I just need to clean it up and point to it. If that's of use, I'm just throwing it out there. I don't know. Last time I looked at it, Doctor wasn't doing a whole lot of that. There was some basic support, but in terms of programmatically building all that crap, it's a big help to be able to just spew it out. So.
Yeah, and then I think it would be really good for all data science stuff as well, to have all this tooling around that one can pick, just put it in their project CLJ or deps.adn, and then it's going to work, and then you can get data from Excel or even PowerPoint if one wants to, or PDFs or whatever, because I'm working in a bank actually. So Excel's files are everywhere, and it's the only way to actually free data, to liberate data, is to go and open up all these files and then collect them and just put them somewhere where then you can clean them up and use this data in much, we hope, in a smart way.
Yeah, man, there's a lot of, we're finding there's a lot of institutional knowledge that's stored in friggin' slides. And we're looking at possibly scraping that and doing, at one point we're looking at throwing that into a search index, but some of this NLP stuff sounds like it might be useful in the business case for extracting legacy information from that stuff. But yeah, it's non-trivial once you start playing with it. It's kind of it's one of those dirty problems that Paul Graham talks about. It's not very sexy, but it ends up being somewhat important. So, but yeah, man, I was going to ask, just out of curiosity, because it popped up on my end, is anybody messing with mathematical programming, linear programming, nonlinear programming, that type of stuff? Because I'm starting to wrap a library. I don't know if anyone's interested in that for some operations research stuff I'm doing for scheduling. But if that's of interest or use, I can publicize that. Although I'm just starting to play with it though.
Oh, it will be surely interesting. Can you talk about it a little bit? I'm sorry, maybe you didn't hear me. I asked if you could talk about. Yeah.
Sorry, man. I must have hit the mute. Anyways,
okay.
Yes. So I got this extra thing on my headset, I guess. In operations research, optimization is a pretty big bread and butter tool we use a lot. We do a lot of mathematical programming, specifically linear programming and mixed integer programming, if that sounds familiar. And so there's a couple libraries out there. You've got like the industrial strength solvers like Scicloj and Jirobi and Mosec and all these like, planet scale optimization problem solvers. And we do some of that, but then a lot of the times you just want something to solve a scheduling problem that's like, say you've got a job scope scheduling thing you want to do with side constraints, and maybe it's just easier to not spend thousands of dollars to get a Scicloj backend or something like that. And so there's a couple of Java libraries out there. The Apache Math Commons has a simplex solver in it that someone wrapped a long time ago in Clojure called Prolin. That was his library, but I play with this kind of out. And there's a new set of libraries it's called OJ Algo, which has like a whole crap. It's one of these like Uber Math libraries as well. And they have like tons and tons of different routines, data structures, and then they also have several solvers. In this case, they have some high-end linear programming and nonlinear programming solvers. So I was looking at that today, and like I said, because I can do it on work time. I can start the project open source and then contribute to it during work. So if that's of use, I'm just kind of networking and throwing it out there. But yeah, OJ Algo, that's it. I mean, I'd heard about that before, that particular library, OJ Algo, but I hadn't really used it until I started messing with it today. And man, they have it's like one of those, like one of those big Uber Math numerics libraries that's just out there that kind of went under the radar for me. I don't know if that was in our original survey when we were talking about this stuff, but it probably should be, because there's a lot of stuff in there we might be able to use. A lot of redundant stuff too, but there's a lot of stuff in there.
Yeah, thanks. No, I don't think we actually had it in the survey. Yeah, we should totally add it. And please, if you can actually open source that, it would be really great, because I think that most of the problems that we're solving with machine learning right now in many companies can be actually solved with solvers or some search smart search algorithms, actually. So
Yeah, I agree with that. I think there's a lot of stuff that's it sounds sexier whenever you have a neural network or something, but in reality, the freaking decades of research and software engineering that have gone into implementing some of these solvers is like they're crushing it, man. They will give you a provably optimal solution. I mean, some of the stuff that's out there. So it's like, I'm less impressed when some people are trying to actually apply neural networks as kind of a cheap, it was really an approximation, but you get an approximately optimal answer and using that as kind of a quick solver. That's something that's kind of, but even then, like with some of these backends, man, like Garobi in particular is kind of cutting edge, man. They're solving planet scale optimization problems fast. And it's just, I'm not as impressed in that domain, but there's definitely use. A lot of these things, like I used Pulp in Python, the Python linear programming package, which has like its own little DSL. I'm trying to look at something like that for wrapping this this OJ algos solver, which is kind of their interface is kind of weird. It's not exactly. It's more like an object-oriented type thing, where you define your variables and you define these expressions, but it's not like a standard. It's a little bit hard to formulate it, the mathematical form that I'm used to with the formal mathematical modeling. So what I'm trying to do is write a little DSL, or at least a nice API in Clojure to wrap it, and then farm that out. And then they allow you to also tag into the different backends if you actually have one of the industrial strength solvers and you don't want to use theirs. Then so just like Julia's got a really good optimization package as well. Something like that. I think that's an area that we don't hear about in Clojure a lot, but I know I deal in that, and I'd love to formulate my stuff in Clojure and solve it. Like if I can solve it locally instead of having to have the client have their own, like I said, $10,000, $15,000 license for something, I can just solve it with a Java library. That'd be pretty badass with Clojure. So, and then on top of that, also there's a friggin' JavaScript optimization library that they've got out there. Somebody written LP solver for that, and I think it does mixed integer programming too. So I was thinking about taking it further and actually having a little Clojure script wrapper so you could do optimization in the browser. This doesn't sound like a great idea, but at least it could be somewhat portable. So, but again, in the area we're dealing with, like I said, I consider this more operations research, at least the domain that I play in. But I figured I'd bring it up. So.
Nice. Actually, I was looking for, and last year I was at Rexis in Vancouver, and they have shown something actually that was really interesting, but I can't find it right now. As soon as I find it, I will share it with all of you. It's basically a solver, but it was built for doing recommendation systems. And it was really, really interesting.
Yeah, I think there's probably some confluence there where you can mix and match these methods, and there's probably some meta stuff there, optimizing the optimization or optimizing a neural network, tuning it. I don't know. Might be some interesting stuff there that hasn't been done yet. But one other thing I wanted to mention, I mean, you've probably seen it on Zulip, but yeah, I continue to kind of dig into some of the stuff that Tomas is working on with the CLJ plot. And what I'd offer out too is if anybody's got any, what I'm trying to get to is I'm trying to find if he's kind of got an interesting implementation that's inspired, quote unquote, inspired by D3 and ggplot and Lattice, I guess, is the rendering package in R. And I'm kind of like going at it from the opposite direction. Is like I'm spelunking through the code and looking at his examples and dissecting it and trying to understand kind of what the underlying formalism, what the formal structures are underneath, and then trying to then map that to other places like Vega and potentially other libraries. If there's anybody that's got any expertise in terms of like, I know I can get around in Vega a bit, and I've looked through libraries like John's and Chris's, but I'm not like, I don't know all the friggin' options and all the properties and all the different fields and all the stuff and all the, there's no, I can read the docs, but there's no like spec in terms of like Clojure spec type thing for to define the grammar that I'm familiar with outside of the papers. And I'm just curious if there's any domain-specific expertise in that or in ggplot. I'm very curious as to if there are some kind of formal specifications for these different plotting constructs, because I'd like to see if there's a way to do machine compilation or some sort of a a transform between the different specifications. Instead of doing a lot of customized boutique hand jammed, I can take, you know, this narrow subset and kind of coerce it to look like a, go from Vega to ggplot or something like that. It's because I think that'll, that might actually buy even more portability, bridging, if you will, if we can define ways to adapt that. Because I think some of Tomas's stuff is pretty cool. And there might be some things in there that you can't do in terms of defining your own custom plot types, actually defining your custom renderers. I mean, really getting down to a level of control that you don't have in the declarative packages. And that's pretty attractive, to me at least. So anyways, that's the other update in terms of what I've been grinding on. I'll keep pumping stuff out in the Zulip. So you'll see more of that.
Joyner, just to be sure that I understood what you're saying, you're suggesting to use the CLJ plot engine as a backend for Vega syntax and for ggplot syntax, right?
Yeah, it's come up a couple of times. Like Chris Nurnberger is asking about it, and it makes sense. They've already got a pretty, you know, you got 10 years or however long Vega's been around, and ggplot's been around longer than that. So you've got a lot of domain expertise and it's kind of this tried and true way of expressing visualizations. So the only thing I don't like about it is it's in the friggin' browser, man. And that's a non-starter for in some cases. You can work around it, or you can, as Tomas did. And if you haven't used his stuff or played with it, it's actually really, really nice how well it integrates with the Clojure functional paradigm. That's the other thing I really like about it. I think John's stuff does as well with how he does the map composition overloading. It's very nice to be able to just use your Clojure stuff to just express this stuff. It's really, really nice to be able to do that. Instead of having to like live within this kind of weird JavaScript, but not quite JavaScript grammar, you know, or an arc, but not quite, you know, this foreign thing that I'm not familiar with. It's very nice. So what I like to do is leverage what Tomas has. And then if there's a way to, what I'm lacking right now is an understanding of how to bridge, formally define a bridge between these kind of external specifications. Like here, Vega has a pretty well-defined grammar, and it gets down to the weeds. You can go from Vega Lite as something much simpler. And then from that, you know, if I've got my, you know, my map specification, I should be able to convert that and coerce it to something else if I know the rules. If I can coerce it to what Tomas has, then we can define ideally mechanical transformations. Like I'm thinking about just specking it out and using Clojure.spec to kind of help to inform that almost from a compiler, like a transpiler level, I guess, source code transformation, something like that. But I mean, that's a little ambitious at this point, but at the very least, I think it would enable a wide swath of, you can take your Vega examples directly off the web and use them with Tomas's stuff. That'd be pretty cool. Or ggplot, you know, something similar from ggplot. At least you can kind of squint at it and it looks close enough to ggplot. But that's long term. For right now, I'm specking out his stuff and trying to understand it and formalize it. And then the idea is if there's some companion formalization, then that would enable the bridging that we talk about all the time. You know, building these bridges. So you get CLJ plot. You can also play with Vega and you can play with ggplot, but that's a ways off.
Yeah. So Vega is probably a bit wider than the things that could be implemented in CLJ plot, because Vega supports interactivity. It supports dynamic plots. But maybe part of it could be.
I interject real quick in that's actually not as far from impossible. CLJ plot actually is designed. It's sitting on top of Clojure 2D, which is basically a process. It's like it's a simpler processing that Tomas wrote. It's like processing or Quill, but instead of having to live inside of the sketch model that they define, their kind of framework, you instead just focus on rendering images, static images, and then you use, it's much more functional, and so that you can then define your rendering now is focused on just, you know, drawing to a buffer, and you have a canvas API and that type of stuff, and then from there you then can animate by, you know, re-rendering that image over time and just changing what you're drawing. So it's a lot more functional and less framework. It doesn't feel like you're like living it, like in processing and Quill. There's always this ambient argument that's kind of hidden from you, which is the current sketch. So everything's very imperative and it's defined with that hidden state, that global state, if you will. where it's not that way in Clojure 2D. So it's actually, if you look at his examples in Clojure 2D, he's got gobs of interactive stuff too. Just straight out of all this generative programming and art books and a lot of processing. You can tell his background, he came from processing. So there's a lot of interactive stuff in there. So I think you could probably do more interactive stuff, even custom interactions that you can't do with the pre-described stuff they have in Vega and Vega Lite, the interactive stuff, in my opinion. Just to, sorry to interject.
Mm-hmm. Yeah, and about ggplot, I think it may be a good idea because ggplot is a very loved syntax that many people are used to. And now we do have it working on the JVM because one of the R ports to the JVM does have ggplot working. It doesn't render correctly, but you do have it working in the sense that you can write the syntax and get the data structure that represents it. And then it is only about translating data structures. And I'm not sure if there is a formal spec for it, but we could do it because it is very well documented.
I didn't even think about that. Because I remember I used Rengen and tried to do some of the ggplot stuff, right? And they're not there yet. You can do some things, but I didn't think about getting the data structure out, because then you could just compile that if you know what the mapping is in theory, you know. I didn't even think about that.
That is a thing that they did in the R world because they do use the ggplot data structure as a way to render to different formats. One format is a picture, another format is a Plotly JavaScript interactive plot, and they both are different renderings of the same data structure with a ggplot data structure. So I guess it is very well documented, and we could invent a new way to render it. And I guess the benefit would be at least being able to do it on the JVM. Yeah, let us try. Yeah, so.
So if no one else has anything to say, okay, this probably be a wrap.
Yeah, take care, you guys. I'm going to have to sign off myself here.
Okay.
Thanks, John.
Yep.
See you soon, I guess.
Yeah, and I'm totally willing to do the walkthrough interview kind of thing with some of this stuff.
Yeah, we will. Let us talk about it.
Yep. Thanks.
Bye.
Thank you. Bye.
Bye. Yeah, guys, it sounds you're running a successful program here, so I think this is a good format. One thing I'd mention, we talk about community interaction typically at the end of these things, right? You guys are leading that up pretty well. I think I would say the thought occurred to me at some point. It may not be a bad idea depending on interest. We talked about meeting up at a conference or something. Depending if we have a consistent group of people that keep coming to these, at least the online ones, and there's some people are actually putting their money where their mouth is in terms of producing and pumping out libraries, or there's product, or there's tutorials. It might not be a bad idea to float the idea about a separate event. If it's one of the things that Carin brought up was there's nobody, there's only the two people that were there that were doing Clojure were at the conference were her and the other person from Cognitect, I think. So if we've done a good job of actually getting a network together of people that are interested in this, that are able to go, well, why don't we go do our own conference or our own little, it doesn't have to be a formal big thing. Like the guys up in Canada did the Clojure North thing, and they just kind of put that together. So, there's something to think about, or at least we've talked about doing like working groups. Maybe I know the Clojure Con just happening, and we're also international, so it's not like it's not trivial for people to fly out here and there, but it may be worth it if it's for the data, if there's an actual concerted effort to get people together. So I'm just floating that out. Might be, again, if this pans out, so far it has. We've had a couple of these, and the group is growing wider, but we also have pretty consistent participation. So if that continues, then it might be a good idea to look at some kind of physical meetup. So.
Yeah, that would be great, actually. What do you think, Daniel?
Yeah, I think it is so important, because after people know each other a little bit, then more things can happen, I guess. And also an opportunity to just work together for several hours is a thing that is a bit rare for some of the people here. And yeah, we should figure out how to do it. And let us keep discussing it, I guess.
Yeah, let's try it. Maybe in the future, let's see how the next couple of meetings go, as Jonar was saying, and then we can discuss how and if it makes sense. I mean, to me, it makes sense, but how to make it possible, maybe.
Yeah. You know, like at the last conch, there were people that were people with actual money behind them, and they were interested in getting the data science stuff, the community working together, and it just seems like there was no leadership. And so what I see now is there's leadership. So all it takes is people pushing that, hey, let's have a conference. Is anybody interested in having a conference? Or is anybody interested in having a workshop? You don't have to call it a conference, right? It doesn't have to be a big formal thing. But if you want to come demo your thing and then participate in some of these talks, then we already have several topics lined up that you could come do, and then throw it up on YouTube or whatever. There's some cost associated, and the problem with that is running the conference or running a workshop. I mean, get together it's not a trivial effort. I don't have any illusions about that, but it might be worth it, man. I mean, there might be somebody who want to step up and do that too. You don't know until you start asking. But yeah, I think it's a good sign, man. So far this has been productive, and kind of makes me a little more optimistic. So hopefully we continue on this track. When you talked about the next, did you say the next meetup was going to be in like June? Was that the thought?
Yeah, so probably it will be about next journal in like one of the 2 last weeks of June, probably. We'll announce maybe next week.
Okay, that sounds good, man. Cool. All right. That's all I got to say.
Okay. Then, guys, it was really, really nice to be with you. I think it was very productive. I really enjoyed Carin's talk and all the stuff that came later in form of the discussion. And I say that we can say goodbye to everyone, and also to all the people watching us through YouTube.
Yeah, thank you so much, Alan. And see you.
Thanks to you. Thanks to everyone. And good night. Of course, if it's night for you. Goodbye.